11.3, the cross product of vectors. We're going to find the product of vectors in space as well as use geometric properties of cross products of vectors in space. So here's a definition of cross product of two vectors in space. So we let u equal this here, u sub 1 times I plus u sub 2 times j plus u sub 3 times k. And v equals v sub 1 times I plus v sub 2 times j plus v sub 3 times k be vectors in space. The cross product in u and v is this vector here. Now this is difficult to memorize, and so there's a shorter way to remember how to do that. One other note that I want to mention is that this applies only to three-dimensional vectors. So the cross product is not defined for two-dimensional vectors. So a convenient way to calculate u times v is to use the determinant form with cofactor expansion shown below. So this 3 by 3 determinant form is just used simply to help remember the formula for the cross product. The corresponding array is technically not a matrix because its matrices are not all numbers. So this is what we're going to do in order to find cross products. So note that the minus sign in front of the j component, so recall from section 8.4 that each of the three 2 by 2 determinants can be evaluated using the pattern below. So remember that we can do a1 times b2 and then minus a2 times b1. Okay, and so that's how we get this formula here. So let's just try that example. Find the cross products. Given u equals I plus 2j plus k and v equals 3I plus j plus 2k. And so we're first going to find u times v. So u times v. And so the first line is going to be I, j, k, and then the next are just the numbers. So 1, 2, 1, and then here we have 3, 1, and 2. Okay, and remember the shortcut, the diagonal method. So I'm just going to rewrite these two columns here. Rewrite these first two columns to the right. So I'm going to rewrite it, and this is going to be I, 1, 3, and then j, 2, 1. And then remember what we do is we add what this multiplies, right? You multiply all of these and then add them together. So this is going to be 2 times 2 is 4i. And then j times 1 times 3 is plus 3j. And then k times 1 is plus k. Then when we're going up here, we're going to subtract these values here. So then this becomes 3 times 2 times k, that's 6k, but we're subtracting it, so negative 6k. Then 1 times I, that'll be minus I. And then 2 times 1 times j is minus 2j. I have a little extra mark here. So now let's combine like terms. So we have 4i minus I. This will be 3i. And then j is next. So 3j minus 2j is minus j. Then negative 6k plus k, that will be a negative 5k. So here is the answer. So let's do it again for v times u. So again, that first row is I, j, and k. And then we're writing v first. So now we write 3, 1, and 2. 3, 1, and 2. And then for u, we write 1, 2, and 1. 1, 2, and 1. And then again, we write the next columns over. So this is I, 3, 1, j, 1, 2, and then we multiply. So this is going to be I plus 2j plus 6k, and then we subtract going up here. So this is negative k minus 4i minus 3j. And so now we're left with I. So this is negative 3i minus j and plus 5k. Last, we have v times v. So again, I, J, K. V is going to be 3, 1, 2. And then V again is 3, 1, 2. Then we rewrite the columns. I, 3, 3. J, 1, 1. Then we're going to multiply here. And so this is going to be 2I plus 6J plus 3K. Then we subtract. So this is going to be minus 2I minus 6J minus 3K. And notice in this case we get 0. So try these three examples here, given u equals I minus 3j plus 2k and v equals 2I minus j plus 2k, and find each cross product. So trying this out, you should have gotten negative 4I plus 2j plus 5k. And the next one, you would get 4I minus 2j minus 5k. And v times v you find is 0. So I'm going to go back to here with the algebraic properties of the cross product. So if you have u times v, notice that it would be the opposite sign, and that's what you noticed probably right at the beginning, is that we get the same answer, but it's just the opposite signs. So notice when we flip them, u times v equals negative v times u. If you have u times v plus w, that's u times v plus u times w. Then with a constant, you can see what happens here. C times u times v. You can multiply c times u and then multiply times v, or the other way, u times c times v. U times 0 equals 0 times u, which is still 0. And then notice u times u, so if you multiply the same vectors together, you should get a 0. Then you have u times v times w. You can just change the parentheses there, so it's u times v times w. The first property listed above indicates that the cross product is not commutative, so remember that. I hope you remember that from previous lessons. In particular, this property indicates that u times v and v times u, they have equal lengths, but they're in opposite directions.